How many ways can you arrange the letters in Harry Potter's summoning charms, Accio? Now, I don't know about you, but my first instinct is to count the number of letters, so in this case there's 5. Establish that I need to arrange all of them, and then just do 5 factorial. Seems simple. Not exactly. Because 2 of the letters, the C and the C, are the exact same letter, there are going to be repeated arrangements. This may be easier to see with colors. Here are 2 of the 120 arrangements that we get if we have the 2 C's distinct, so that we consider them differently. The first one, we've got A, red C, blue C, I, O. The second one, we've got A, blue C, red C, I, O. Oh, that should have been yellow. When we color the letters, we can see that the 2 C's are different because this physically looks different than this one. Except when we're writing out words, for the most part, unless specified otherwise, C and C is the exact same. So if I write A-C-C-I-O and I write A-C-C-I-O, really, those are the exact same. So I don't want to account for any time I'm repeating those. So anytime we have repeated letters, we kind of use the exact opposite of our product rule. So because we're trying to remove cases, we end up dividing. So in our case, we start off with 5 total letters, and we want to remove the cases that have the same letters essentially repeated. So in our case, we've got 2 of the same letters, so we divide by 2 factorial. And that's equal to 60. Let's try 2 more words. So if I want to figure out the number of arrangements of the letters in the name Samantha, for example, I would first start off by counting how many letters are actually in the name. So we've got 8. Put that in our numerator. Then see if there are any repeated letters. So there are 3 A's. Okay, everything else is unique. So I'm going to divide 8 factorial by 3 factorial. And that's equal to 6,720. Next word, Toronto. So in this case, I've got 1, 2, 3, 4, 5, 6, 7 total letters. So we'll start with that. And now let's start looking at our identical letters. So we've got 2 T's, and we've got 1, 2, 3 O's. Okay, so this time we have more than one identical item. So all we got to do is divide. First, we'll start with the T's. We'll do the 2 factorial for the T's, and then we're going to do 3 factorial for the O's. Simple as that. And that's equal to 420. So in general, when you're working with arranging items that have identical terms, you put your total number of items in the numerator, take the factorial of it, and then divide by the number of items that are identical, factorial. And of course, if you have more than one identical item, you can just continue and put them in the denominator. Good luck, guys.